Thanks. Matthew Barker. I'm a solution architect for Twistlock. Today will be the only talk at DevOpsDays Kansas City that is wardrobe driven. So this is the Twistlock logo. It looks a lot like a Rubik's Cube. So sometimes Docker security can be quite puzzling. So today I'm going to help you through it. And we're going to explore hidden defects in your containers. So let's first talk about the advantages of Docker. Short-lived, small, task-specific containers have a much smaller attack surface, and they lead to good security practices. We're going to use all of those as we show you the best practices. Docker is exploding. 7,000 pulls per minute. That's a very impressive consumption rate. What could possibly go wrong? Love the shark instead of the whale there. So first, let's look at our inventory of images on Docker Hub, not on GitLab. So the thing that's most alarming here is half of the latest images have vulnerabilities, almost half. Now let's look at our components that make up our applications. About 7% of the components have high-level vulnerabilities. Real problem. Now let's dive into our Docker containers. There's a lot of moving pieces here. There's a lot of things that can go wrong, and so you need comprehensive security practices in this environment. We're going to start out by looking at a simple web app based on Tomcat. We're installing SSH server, and we're adding our application as a WAR file. Looks really simple. What could go wrong? Well, the Tomcat base image has 27 high-level vulnerabilities in the SDK, in utilities, in the OS. We're going to remediate this here in a little bit. The OpenSSH server was made famous with Heartbleed. These vulnerabilities shown here aren't Heartbleed, but they could be the next Heartbleed if you used this version of OpenSSH. And then finally, our web application has 6 high-level vulnerabilities in 3 components. There's usually a fix for every vulnerable component or binary. So in this one, it's fixed in 3.2.2. And then finally, I don't know if you're familiar with the Center for Internet Security, but they publish Docker standards. I would recommend that you try to make your containers comply to those. In this case, we have a private key stored in an image and containers running as root. So how do we secure all of this? The first step is to utilize and build secure and compliant images. The second step is to maintain a clean inventory of images in your Docker repository. Update that frequently and continuously verify. Keep that clean. That is your inventory for your entire enterprise. Finally, be vigilant and lock down your deployments. Deploy frequently and include runtime protection of your running containers. If you have an automated solution, even better. Now, let's go back to our web-based application. We're now going to use an Alpine image that Tomcat is built on top of. With Alpine behind Tomcat, that cat doesn't look quite so suspicious anymore. We're also going to use a secret vault and get rid of secrets from your image. CyberArk's one of the, I brought my secret CyberArk socks. I'm wearing them today. So be sure and inject secrets in your containers and don't put them in your image. Finally, secure the app layer. Do source code scanning, but also scan your binaries. Do it as early as possible in the IDE, or your CI is best. Finally, components, images, and binaries, they age like milk, not like wine. So be sure, just because an app is deployed, make sure you have a tool that's going to alert you if a new vulnerability comes up. Take the lesson of Equifax. They used a vulnerable version of Struts 2. 143 million people's private records were released. And there was a fix for that 2 months before the breach. So if you want more information about today's topic, email me at matthew@twistlock.com. I'll be glad to send you these slides, and I'll send you my top 10 security best practices for Docker containers. Thank you.